Hello students. So today I am doing class for class 12 science. The topic is inverse of a given matrix. So in the last online class also we were doing some problems in the chapter matrix. So this is your continuation chapter, that is the topic is inverse of a given matrix. That means how will you get the inverse of a given matrix. So first of all you should know these 3 points, that is first one is minor of an element of a given matrix. That is what is meant by minor of an element of a given matrix, or how can you find out the minor of an element of a given matrix. Then after that, number 2 point is you have to find out or you should know how to find out the cofactor of an element of a given matrix. And the third one is how to get the adjoint or adjugate of a given matrix, or what do you mean by adjoint or adjugate of a given matrix. Okay, so let us discuss about the topic 1, that is minor of an element of a given matrix. Okay, so now let us discuss this point. What do you mean by minor of an element of a given matrix? Okay, so now let us assume the matrix A as second order matrix. Let us assume this matrix. Let capital A is equal to A11, A12, A21, A22, right? So A11 means this is the element in the first row and first column. A11 is the element in the first column and in the first row. That means I told you already that this one represents row and this one represents column, right? So A11 is the element in the first row and in the first column. So likewise A12 represent the element which is in the first row and the second column. Is that clear? So A12 means this represents row and this represents column. That means A12 is the element in the first row and the second column. Okay. Similarly A21, what does it mean? A21 means the element in the second row and in the first column. And what is A22? A22 represents the element in the second row and in the second column. That is A22 is the second element of the second row and the second column. Is that clear? So now how will you get the minor of an element of a given matrix? So minor of an element of a given matrix is denoted by, suppose it is M11. So minor of an element, that means M11 is the minor of the element A11. This one represents the row and this one represents the column. That means this one represents the row and this one represents the column. M11 means the minor of an element small a11 of the matrix A. So what is meant by it? So M11 is the minor of the element A11, is the minor of the element A11, which is obtained by deleting the row and the column through the element A11. Is that clear? The यहाँ के भन्नु खोज्यो भन्दाखेरि यो A11 को माइनर चाहिँ कुन चाहिँ हो? क्यापिटल M11 हरे सपोज. यो चाहिँ हामी कसरी निकाल्छौं? यो चाहिँ कसरी निकाल्छौं भन्दाखेरि सपोज यो हामीले A11 एलिमेन्ट को माइनर निकाल्दै छ भने you have to delete the row and the column through the element A11. That means through the element A11, if you delete the first row and the first column, then you will get A22. That means what is the minor of the element small a11? It is A22. It is your A22. So the minor of an element of a given matrix A is obtained by deleting the row and the column through that element A11. That means A22 will be the minor of the element A11. Okay, so this M11 means minor of small a11, right? So similarly, what do you mean by M12? This one represents, this first one represents row, and the second two, this represents column. That means M12 means minor of what? A12. That is here capital M12 small a12. That is minor of which element? A12. What is the minor of the element A12? The minor of the element A12 is obtained by deleting the row and the column through the element A12. You have to delete the row and the column through the element A12. That means this first row and the second column should be deleted. What do we get? A21. So which is equal to, this is A21. So what is the minor of the element A12? It is small a21. Similarly, what is the minor of the element A21? Minor of the element, what is the minor of the element A21? It is represented by capital M21, which is obtained by deleting the row and the column through the element A21. So you have to delete the row and the column through the element A21. That means you have to forget about this second row and the first column. So what do we get? A12, right? So A12, which is equal to, this is the minor of which element? This is the minor of the element A21. Okay, so next one is M22. What do you mean by M22 now? What do you mean by M22? M22 is the minor of the element small a22. So M22 is the minor of small a22, which is obtained by deleting the row and the column through the element a22. That means you have to delete the second row and the second column. What do we get? A11. So A11 will be the minor of the element small a22. Is that clear? So how can we define minor of an element of a given matrix? The minor of an element of a given matrix is obtained by deleting the row and the column through that element. Is that clear? So this is an example. So let us write down the definition of minor of an element of a given matrix. Okay? So the definition is, minor of an element of a given matrix is obtained by deleting the row and the column COLUMN and the column through the element. So I think you have understood the minor of an element. Okay. So now let us find out the minor of an element of a given matrix of third order. Okay. So now let us find out the matrix of an element of a matrix of, let us find out the minor of an element of a given matrix of third order. Okay. Suppose you have capital A is equal to A11, A12, A13. So A21, A22, A33. This is A23. Next one is A31, A32, A33. So what do you mean by A22? A22 is the element in the second row and the second column. That is this one, A22. What do you mean by A31? A31 is the element in the third row and the first column. What do you mean by A13? A13 is the element in the first column and the third row. Is that clear? So how can you find out the minor of the element A11? So M11, that is minor, suppose minor of the element small a11 is represented by M11. Now in this case, this is the third order determinant. So how can you find out the minor of the element? Small a11, it is represented by m11. So minor of the element, that according to the definition, minor of an element of a given matrix is obtained by deleting the row and the column through that element. That means minor of the element small a11 is obtained by deleting the row and the column through the element. That means what remains out here? A22, A23, A32, A33, isn't it? If you delete the row and the column through the element A11, that means you have to delete the first row and the first column. That means what remains here? A22, A23, A32, A33. That means you have to write it in terms of determinant form. That is, you get A22, A23, A32, then A33. Then you can expand it. So you know how to expand the second order determinant, isn't it? That is, it will be A22 into A33 minus A23 into A32. So likewise, how can you find out the minor of the element A32 now? How can you find out the minor of an element A32? It is represented by capital M32. That means M32 is the minor of the element A32. So it is obtained by deleting the row and the column through the element A32. That means delete the third row and the second column. So what remains? A11, A13, A21, A23. So in that case, you have to write it in terms of determinant form. So what remains here? A11, A13, A21 and A23. Is that clear to all of you? Similarly, you can find out the minor of the element A22. It is represented by capital M22. That means it is the minor of the element, which one? A22. Minor of the element which belongs to the second row and the second column. That means A22. Is that clear? So it is obtained by deleting the row and the column through the element A22. That means you have to delete the second row and the second column. What remains? A11, A13, A31, A33. That means A11, A13, next one is A31, then comes A33. Is that clear to all of you? Now you can find out the minor of any element in this matrix A. Is it clear to all of you? So this is how to find out the minor of an element of a given matrix. Now let's discuss about the cofactor. So now let us discuss about the cofactor, right? So number 2 is cofactor of an element of a given matrix. So let us discuss about the cofactor of an element of a given matrix. Okay. So now, what do you mean by cofactor of an element of a given matrix? Okay, so that means how will you get the cofactor of an element of a given matrix? So in case of minor, we did not consider any sign, whether it is plus or minus, isn't it? But in case of cofactor of an element of a given matrix, you have to consider the sign also. It may be plus, it may be minus. So how will you get plus or minus sign in case of cofactor of an element of a given matrix? Okay. So let us consider an example. Suppose A is what? Second order matrix. Okay. Suppose it is A11, A12, A21 and A22. Now it is just like your minor. So in minor, how did you get the minor of an element of a given matrix? It is obtained by deleting the row and the column through that element concerned, right? So in case of cofactor also, you will get the cofactor of an element of a given matrix by deleting the row and the column through that element concerned, but you have to consider the sign also. So how can you get that sign in this case? Okay. So the cofactor of an element of a given matrix is denoted by capital A11. In case of minor, we denotate it by capital M11, it may be capital M12, it may be capital M21, etc. Okay. So in case of cofactor of an element of a given matrix, let us represent it by the capital letter A. So it is, and also you have to give the suffix here, capital A11. What does it mean? Capital A11 भनेको चाहिँ के हो भन्दाखेरि cofactor of the small element small a11. It is capital A11 means cofactor of the small letter small a11, right? That is A11 means cofactor of the element. Cofactor of the element. Which element? If it is given 1 you have to take small a11. So it is also obtained by deleting the row and the column through that element concerned, but you have to consider the sign also. So how can you get that sign now? You always take -1. You always take what? -1. So in order to get the cofactor of an element of given matrix, you have to take always -1 to the power. Since it is given 1 1, here it is given 1 1, it should be this row plus this column. That is 1 plus 1. If it is given A11, 1 plus 1. If it is capital A21, it should be 2 plus 1. If it is capital A22, it will be 2 plus 2 and so on. Right? Then you have to write down the minor of that element A11, which is given by capital M11. Okay? So which is equal to, what is -1 all to the power 2? It is always plus 1. So plus 1 usually we don't write. So what is the minor of this element small a11? What is the minor of this element small a11? It is obtained by deleting the row and the column through that element a11. That means what do we get? A22. So it will be A22. Is that clear now? Next, how can you get the cofactor of the element small a12? The cofactor of the element small a12 is represented by capital A12. Capital A12 means cofactor of small a12. So how is it obtained? You have to consider the sign. The sign will be given by -1 always, whole to the power. Since it is given 1 plus, which is the column? Second column, that is 2. Then you have to write down the minor of the element A12, which is obtained by deleting the row and the column through that element. That means first row and second column are deleted. What do we get? A21. So it is A21, which is equal to, what is -1 whole cube? So it is -1 whole cube into A21. What is -1 whole cube? Minus is multiplied thrice. Minus into minus plus, plus into minus minus. That is minus A21. Right? So this minus A21 will be the cofactor of what? Small a12, which is represented by capital A12. Is that clear? Next one, capital A21. That means, what is the cofactor of the element small a21, which is obtained by considering the sign -1 whole to the power 2 plus 1 again. This is 2 plus 1, right? This is your 2 plus 1. And you have to delete the row and the column through the element small a21. That means first column and second row are deleted. What do we get? A12. A12, which is equal to -1 whole cube, right? So -1 whole cube, then what do we write? -1 whole cube, then what do we write? It is A12, which is equal to what? What is -1 whole cube? That is minus A12. Is that clear? So similarly, A22. A22 means cofactor of the element small a22. Cofactor of the element which is in the second row and the second column. That is small a22. So which is obtained by considering the sign. How can you get that sign? -1 whole to the power. This first is 2 plus second is also 2. Now delete the row and the column through the element small a22. Delete the row and the column through the element small a22. That means forget about the second row and the second column. What do we get? A11. So which is equal to -1 whole to the power 4. A11 is equal to, what is -1 whole to the power 4? -1 whole to the power, even number is always plus sign, you know that. So it is A11. Is it clear now? So now let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors. Let B be the matrix whose elements are the cofactors of the elements. Let B be the matrix whose elements are the cofactors of elements of matrix A. Of elements of matrix A. Right? So therefore, what is capital B is equal to? So हामीले यहाँ B के suppose B चाहिँ एउटा matrix हो whose elements are the cofactors of the elements of matrix A. So capital B is equal to, what do we write here? Capital A11, capital A12, capital A21, capital A22, which is equal to, what is the value for capital A11? You should write small a22 here. What is the value for capital A12? It is minus A21. What is the value for A21? It is minus A12. Minus A12. And then what is the cofactor? What is the value for A22? What is the value for A22? It is A11. Is that clear? So this is the matrix B. Okay? So B check here is let B be the matrix whose elements are the cofactors of the elements of matrix A. The matrix A बाट जुन cofactor निकाल्यौं त्यो cofactor लाई चाहिँ हामीले फेरि matrix form मा लेख्यौं त्यो matrix form लाई चाहिँ हामीले के डिनोट गर्यौं that is capital B. बुझ्दैछ? अच्छा नेक्स्ट यो जुन चाहिँ हामीले B matrix बनायौं यसलाई पनि हामी ट्रान्सपोज गर्छौं त्यो ट्रान्सपोजलाई चाहिँ भन्छ adjoint of the given matrix. That is, the adjoint of the given matrix A is defined as the transpose of B. Okay? So यहाँ हामीले के गर्यौं पहिला एउटा given matrix थियो A is equal to हामीले लेख्यौं A11, A12, A21, A22. Then we found out the cofactors of the elements, cofactors of each and every element of the matrix A. Then we got this B matrix. Okay? That is capital A11, capital A12, capital A21, capital A22. So if you transpose this matrix B, then you will get the adjoint of A. So the adjoint of the given matrix A is defined as the transpose of this matrix B. Okay? So you know adjoint or adjugate AD. हामीले स्पेलिङ कसरी लेख्छौं ADJOINT adjoint अनि adjugate एउटै मिनिङ हो यसको adjoint and adjugate have got the same meaning. The यसको abbreviation चाहिँ के हो ADJ. So we don't write adjoint, we don't write adjugate, but we just write ADJ only, ADJA. So it is meant that ADJA is the adjoint or adjugate of the given matrix A. So adjoint of the matrix A is represented by ADJ only. It represents adjoint or adjugate. Okay? So ADJA भनेको चाहिँ के रहेछ B transpose. That is rows like columns or columns like के बनाउँछौ rows बनाउँछौ. So what do we get now? Therefore ADJA is equal to, what is the transpose of B out here? So in the matrix B, you have to change rows into columns and columns into rows. That means this first column becomes the first row out here. That is A22 minus A12, and then next one is, it is minus A21, and this is A11. This is the adjoint of the matrix A. Okay? So this is the example from the second order matrix. So you can copy it. Okay? So now let us take the example from the third order matrix. Okay. So now let us take an example. Let us take example of third order matrix, that is 3 rows and 3 columns. Let capital A is equal to A11, A12, A13. Next, A21, A22, A23. Next, A31, this is what? 32, and this is A33. Right? So now, therefore, now how can you get the cofactor? Cofactor of all these elements in the matrix A. Okay? So capital A11 is equal to, this capital A11 means cofactor of this small a11. So how is it obtained? You have to consider the sign also. How can you get the sign? It is, you have to write always minus 1 whole to the power. 1 is given out here. So it should be 1 plus 1. Now, you have to delete the row and the column through the element concerned. Through the element concerned. That is small a11. That is, you have to delete the row and the column through that element a11. That means, forget about the first row and the first column. So what do we get? You have to write it in case of, in terms of determinant. That is, it remains A22, A23, A32, A33. That means you will get A22, A23, and this is A32, and this is A33. So this is your A, capital A11. Capital A11 means cofactor of small a11. So which is equal to cofactor of small a11. So you can easily expand it. This is minus 1 whole to the power 2 is there. If it is minus 1 whole to the power 2, it is always plus sign, and you can expand this determinant. Is that clear? Similarly, how can you get a12? So what is my capital A12? That is cofactor of small a12. So it is obtained by considering the sign. It is obtained by considering the sign. How can you consider the sign? Minus 1 whole to the power. Since 1, 2 is given, it is 1 plus 2. And you have to delete the row and the column through the element A12. That means you have to delete the first row and the second column. So what remains? A21, A23, A31, A33. But you have to write it in terms of determinant. That is, what do we get? A21, A23, then A31, then A33. So which is equal to, that is the cofactor of which element? Cofactor of which entry? Small a12. Small a12. Is that clear now? So similarly you can get capital A13, capital A21, capital A22, capital A23, capital A31, and so on. I think you have understood it, isn't it? Suppose if you want to get the cofactor of small a32, it is represented by what? Capital A32, which is obtained by writing minus 1 whole to the power, this is 3 plus this is 2, and you have to delete the row and the column through which element? Since 32 is given, small a32. That means this third row and this second column are deleted. So what remains? A11, A13, A21, A23. Clear? So it is A11, then comes what? A13, then comes A21, and then comes A23. Is it clear? That means, which is the cofactor of what? Which is the cofactor of small a32? Small a32. Is that clear? Similarly, you can find out the cofactor of the other elements in the matrix A. So I think you have understood it. So you can copy it. So now you know how to find out the cofactors of each and every element in the matrix A. Now let us write, let capital B be the matrix, let capital B be the matrix whose elements are the cofactors, whose elements are the cofactors of the elements of matrix A. Let B be the matrix, let capital B be the matrix whose elements are the cofactors of the elements of matrix A. Okay? Let capital B be the matrix whose elements are the cofactors of the elements of matrix A. अब हामी matrix B बनाउँदै छौं, जुन चाहिँ matrix B मा चाहिँ each and every element will be the cofactors of the elements of matrix A. That is, we have represented it by capital letter A11, A12, A13, then A21, then comes what? A22, then comes A23, then it is A31, then A32, then it is A33. Clear? So this matrix B is the matrix whose elements are the cofactors of the elements of matrix E. Okay? So if you transpose this B, what do we get? That is the adjoint or adjugate of the matrix E. So if you transpose this B, what will you get? That is the adjoint or adjugate of the matrix E. That is ADJ A is defined as the transpose of B. So which is equal to, what is the transpose of B now? Transpose of B now means that is A11, A21, then comes what? A31. Is that clear? Then comes this second column becomes the second row. A12, A22, A22, then comes A32. Is that clear? Next, this third column becomes the third row. That is A13, A23, and then A33. Then it is A33. So this is the adjoint of the given matrix E. Okay, is that clear now? So we have learnt how to get the minor of an element of a given matrix, and in the second case we learnt how to get the cofactor of an element of a given matrix, and in the third case we learned how to get the adjoint or adjugate of a given matrix. Okay, now let us find out the inverse of a given matrix. Okay, so now we'll discuss about the inverse of a given matrix, or how can you get the inverse matrix of a given matrix. Okay, now let us know the meaning of inverse of a given matrix. Suppose two matrices A and B are given, right? Suppose the two matrices A and B of the same order, it should be a square matrix. A and B should be of a square matrix of the same order. Suppose A and B are the two matrices, are the two square matrices, and they are of same order. And if you can find out that AB is equal to BA is equal to I, then either A is said to be the inverse matrix of B, either A is said to be the inverse matrix of B, or B is said to be the inverse matrix of A. So let A and B be the two square matrices of the same order, and if you can find out that AB is equal to BA is equal to I, where I is the unit matrix of the same order, then we say that either A is called the inverse of the matrix B. It is denoted by A is equal to B to the power minus 1. That is, it is read as B inverse. But you cannot read it as B to the power minus 1. It is read as B inverse. Or B is said to be the inverse of the matrix A. And it is denoted by B capital B is equal to A capital A inverse. Is that clear now? So this will be the definition of the inverse of a given matrix. So let us write it. Definition: let capital A and capital B be the two square matrices. Be the two square matrices of the same order such that AB is equal to BA is equal to I, where I is the unit matrix, or it is also known as identity matrix, isn't it? Where I is the unit matrix, or it may be identity matrix also, right? Where I is the unit matrix of the same order, then A is called inverse of B, that is A is equal to this B inverse, B to the power minus 1. But you cannot read it as B to the power minus 1. You should read it as B inverse, okay? Or B is called inverse of A, that is B is equal to A to the power minus 1, or A inverse. Is that clear? So this is the definition of inverse of a given matrix. So now you can copy it. That is the definition of inverse of a given matrix. So now, in order to write down the formula of inverse, in order to write down the formula to get inverse of a given matrix, let us consider this theorem. Okay? So if capital A is a given square matrix of order n, it may be n is equal to 2, it may be n is equal to 3, and so on, right? Then it can be shown that A into adjoint of A is equal to adjoint of A into capital A is equal to, this is known as modulus. Within modulus sign A is written, that is known as det A. So suppose this is the given matrix A. If you want to find out det A, you have to write it as either det A, or you can write it within mod sign also. That is the meaning is det A. So det A means, suppose the square matrix A is given. So det A means you have to convert that square matrix in terms of determinant. So if you can convert that square matrix in terms of determinant, you can easily expand it. Okay? So determinant of A is obtained by writing within mod A, which is equal to, you can expand it. You can also expand it. Okay? You know how to expand the square determinant of order 2 and order 3. So you can easily get det A or within mod A. Within mod A. So within mod A means that is your det A. Okay? So I'll show you how to get det A. So let us first discuss about this theorem. So how can you show that A dot adjoint of A is equal to adjoint of A dot A is equal to within mod A dot I. So here I is the identity matrix of order n. Okay? So here you have to find out adjoint A also. A matrix A is given out here. Let us take an example to prove it. Okay? So now let us take an example to prove it. Okay? So let matrix A is equal to, suppose 1, 2, 3, 4. Now you know how to get the adjoint of A. This is a given matrix A, this matrix A. Let us find out det A. So how can you find out det A now? So therefore det det A, or you may write it as within mod A. Now you can change this matrix into determinant form if you write det A or within mod A. Okay, so 1 2 3 4. So which is equal to, what is it? So you can expand it. This is 4 1s are 4 and minus 3 2s are 6, which is equal to minus 2. So I think I've understood it. Now we have to get the adjoint of A. In order to get the adjoint of A, you should know the cofactors of each and every element of matrix A. That is, let us find out the cofactor of A11. Cofactor of small a11 means, which is the element in place of a11? That is element in the first row and the first column, that is 1. That means you have to find out the cofactor of this number 1. Okay, so it is minus 1. You have to consider the sign also in order to get the cofactor. Minus 1 whole to the power, since 1 is given out here, 1 plus 1. Now delete the row and the column through this element 1. Delete the row and the column through this element 1, that is first row and first column are deleted. What do we get? 4. So which is equal to, this is minus 1 whole square into 4, which is equal to 4. You know this, right? Next one is capital A12. What do you like capital A12? You have to find out the cofactor of small a12. That means first row and second column. First row and second column is this one. First row, second column is this element 2. That means you have to find out the cofactor of this 2. So how can you get it? You have to consider the sign minus 1 whole to the power 1 plus 2. Now delete the row and the column through this element 2. Delete the row and the column through this element 2. That means first row and second column are deleted. What remains? 3. So which is equal to minus 1 whole cube into 3. Which is equal to, what is minus 1 whole cube? Minus is multiplied thrice. Minus into minus plus, plus into minus is minus. That is, it is minus 3. Clear? Next one is, let us find out A21. What is by A21? What is meant by A21? That is cofactor of small a21. That means element belonging to the second row and first column. Second row and first column is this one. That means you have to get the cofactor of this 3. So how can you get it? You have to consider the sign first. So how can you consider the sign? Minus 1 whole to the power 2 plus 1. And now we have to delete the row and the column through this element small a21. That is element belonging to the second row and the first column. Second row and the first column. That means 3. So delete the row and the column through the element 3. That means first column and second row are deleted. What remains? 2. So which is equal to minus 1 whole cube into 2, which is equal to, this is your minus 2, right? Similarly, how can you get the cofactor of small a22? Capital A22 means cofactor of small a22. Small a22 means element belonging to the second row and the second column. Second row and the second column. That means 4. So you have to consider the sign also. That is minus 1 whole to the power 2 plus 2, you know that, 2 plus 2. This is written out here. Now delete the row and the column through the element 4. That is second row and second column are deleted. What remains? 1. So into 1, which is equal to minus 1 whole to the power 4 into 1, which is equal to 1. So actually we are proving this relation, right? So next. So next one is, let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors. Whose elements are the cofactors of the elements of matrix A. Of matrix A, right? So therefore, what is capital B is equal to, how much is it? A11, A12, A21, and this is capital A22, which is equal to, what was capital A11? It is 4. What is capital A12? It is -3. -3, right? What is A21? What is its value? It is -2, right? So it is -2. And what is the value for capital A22? It is 1 only. It is 1. So this is your matrix B. Is that clear? So we have taken A is equal to 1, 2, 3, 4. Okay, we'll write here. And what was date A? Date A was -2, or within mod A is equal to -2. Within mod A means that is your date A, right? So we got the matrix B. Now next, let us find out ADJA. So what in by ADJA? I just told you this one, ADJA, that is adjoint or adjugate of A. How is it? How is it determined? That is the transpose of B. That is transpose of B is defined as the adjoint or adjugate of A. So which is equal to, this is your B transpose. That is ADJA is equal to, what is B transpose out here? This first column becomes the first row, 4 minus 2. You have to change rows into columns and columns into rows, you know that. And then comes -3, 1. Right? That is your adjoint of A. Is it clear? So next, let us find out that relation A dot adjoint of A. Therefore, A dot adjoint of A. Let us find it. Okay? So is equal to, what is A? A is the given matrix, square order matrix, that is 1, 2, 3, 4. 1, 2, 3, 4. Right? And what is adjoint of A? We just found it. That is, it is 4 minus 2 and then -3, 1. Right? So this is the adjoint of A. So let us multiply them. You know how to multiply these two matrices, isn't it? So let us multiply these two matrices. You know how to multiply them, right? So first row is multiplied by first column. 1 4s are 4. 2 into -3, -6. First row is multiplied by second column. That is 1 into -2, -2. And then +2, +2, right? Next, second row is multiplied by second column, but the corresponding elements should be multiplied. 3 4s are 12. 4 into -3, -12, right? Next one is, this second row is multiplied by the second column. 3 into -2, -6. 3 into -2 is -6, plus 4 ones are 4, plus 4. Is that clear? So which is equal to, how much is that now? How much is that? It is -2, 0. This is 0, that is also -2, which is equal to, what is common out here? You can take common throughout the term in matrix. -2, it is 1 0 0 1, which is equal to, actually what is -2? -2 is date A, right? So you can write here date A or within mod A into dot I. So we have proved that date A dot I, that is A dot adjoint of A is equal to date A dot I. So I think you have understood it. Okay. So let us find out ADJA dot A again. So let us find out again ADJA. You first write it ADJA, then dot A, which is equal to, what is ADJA? What is ADJA? Actually, it is 4 minus 2, 4 minus 2, then -3 1. Now this matrix is written first, right? This matrix is written first. Then what is A here? A is, as you know, that it is 1 2 3 4. It is 1 2 3 4, right? So let us multiply these two matrices. You know how to multiply these two matrices, isn't it? So you can multiply them. First row is multiplied by first column. This first row is multiplied by first column. 4 ones are 4 minus 6. Right? Next, first row is multiplied by second column. 4 twos are 8 minus 8. Right? Second row is multiplied by second column. Minus 3 into 1. Minus 3 plus 1, 3s are 3. Again, this second row is multiplied by second column. Minus 6. And then this is plus 4. Is that clear? So which is equal to, how much is it now? This is minus 2, this is 0, this is also 0, this is also minus 2. So in case of matrix, throughout the term, you can get common here. So here minus 2 is taken common. What do we get? 1, 0, 0, 1, right? So which is equal to minus 2 dot, this is your I. Actually, what is minus 2? It is det A, or you can write within mod A, that is det A dot I. So what is proved here? Actually, we have proved that theorem. So I think I have copied it. So therefore, we have proved that A dot ADJ A is equal to ADJ A dot A is equal to within mod A or det A. It is written actually det A dot I. Understood? So this is the important theorem. Okay? And you have to remember it also. So from here, how can you get the inverse of a given matrix? Okay? So now let us take first is equal to third. That is A dot, you may take second is equal to third also. Okay, let us take first is equal to third. A dot ADJ A is equal to within mod A dot I. Okay? Now let us multiply both these terms by A inverse, because you have to get A inverse, isn't it? So or A inverse, this is A inverse dot A into ADJ A is equal to within mod A dot A inverse dot I. So now you know properties of matrices. I already told you that. What is A inverse dot A? That is your I dot ADJ A, right? So which is equal to within mod A dot. What is A inverse dot I? It is just like 2 ones are 2. So what is A inverse dot I? What is the property here? This is A inverse. Okay? So or what is I dot ADJ? It is just like I told you that A inverse dot I is A inverse. Similarly, likewise, what is I dot ADJ A? It is only ADJ A is equal to within mod A dot A inverse. So what is the formula for A inverse is equal to? It is 1 upon within mod A into, this is your ADJ A. So this is the formula. So this is the formula, you should remember it. And since this within mod A or det A is in the denominator, it should not be equal to 0. So where within mod A should not be equal to 0. If it is equal to 0, then it is undefined. You cannot get A inverse. So in that case, A inverse does not exist if within mod A is equal to 0. Okay? So there is a definition of singular matrix and non-singular matrix. I will also tell you about these two matrices, that is singular matrix and non-singular matrix. Okay? So if det A is equal to 0, if you can find out the determinant of A is equal to 0, then this is known as what? Singular matrix. This is defined as what? Singular matrix. If det A not equal to 0, then this is known as what? Non-singular matrix. This is known as non-singular matrix. This is known as non-singular matrix. That is, if you can find out if the matrix A is given and if you can find out that A is equal to 0, then the matrix A is said to be singular matrix, but it should be of square order, right? As next, if that A not equal to 0, then that square matrix A is said to be non-singular matrix. So this formula is very important in order to get the inverse of a given matrix. Is that clear to all of you? So what is the formula for the inverse of the matrix A is equal to 1 upon det A into, in the numerator there is adjoint of the matrix A. So this formula is very important. You should know it. So I think you have understood the derivation of the formula for how to get the inverse of a given matrix. So this is the formula, right? So you should know this formula. So A inverse is equal to 1 upon det A into adjoint of A. Is that clear to all of you? So let us find out the inverse of a given matrix. Let us do some problems now. So now we'll do this problem number 1. This is from exercise 3. Book is Higher Mathematics for class 12 by Sailendra. Exercise 3, page number 214. So the section is each question carries 5 marks. Okay. So question number 1 is find the adjoint and inverse of each of the following matrices. So I think you have understood the theory portion, I think. Okay, you can revise it at home. So if you have any doubt, the katai ke bujeko chaina bhane तिमीले मलाई comment गर्न सक्छौ, or you can call me also. Okay, so find the adjoint and inverse of each of the following matrices. That is number 1. Let us find out the inverse of this matrix, that is 2, -1, -4 and 3. This is the second order matrix. Let us assume it as capital A. The matrix is denoted by capital letter. You know that, isn't it? So capital A is equal to, let us write it as 2 -1 -4, 3. So you have to find out det A or within mod A, isn't it? Let us convert it into determinant form. So you know how to convert it into determinant form. This is the first bracket. You should write all the elements of the matrix in between the two vertical lines. That is your determinant sign. Okay? So it is just like within mod also. So this is the vertical lines, 2, -1, and this is -4, and this is 3. So which is equal? Now we can expand it. Let us expand it. 2 3s are 6, then comes minus. So -4 into -1 is +4, isn't it? +4, which is equal to 2. That is not equal to 0. That means A inverse exists. Because you know that the formula for A inverse is equal to 1 upon det A into adjoint of A. And det A is in the denominator, so it should not be equal to 0. If it is equal to 0, then A inverse does not exist. So here you should write A inverse exists. So I think you have understood it. Now, in order to get the inverse of a given matrix, you should know the cofactors of each and every element of the matrix A. Okay? So let us find out the cofactors of each and every element of the matrix A. That is capital A11. What is capital A11? This is the cofactor of the element in the first row and in the first column. First row and first column. That means 2. You have to find out the cofactor of the element 2. You have to consider the sign also in case of cofactor. -1 root to the power. This one 1. 1 plus 1. Now delete the row and the column through the element 2. First row and first column are deleted. The row corresponding to 2 is first row, and the column corresponding to 2 is the first column. Delete the row and the column through the element 2. That means it remains 3, which is equal to -1 whole square into 3, which is equal to 3. Is that clear? Next comes A12. What is A12? Element belonging to the first row and second column. First row and second column. That means minus 1. Now you have to find out the cofactor of minus 1. You have to consider the sign first. Minus 1 whole to the power 1 and 2 are given out here. It is 1 plus 2 into. Delete the row and the column through the element minus 1. That means first row and second column are deleted. What remains? Minus 4 into minus 4 is equal to. So this is minus 1 whole cube into minus 4. What is minus 1 whole cube? Minus is multiplied thrice. Minus into minus plus. Plus into minus is minus. So minus into minus is plus. That means plus 4. I think you have understood it. Okay. Next. Which one? A21. You have to get A21. That is cofactor of the element belonging to the second row and first column. Second row and first column. That is minus 4. Right? Now we have to consider the sign. How can you write down the sign? Always minus 1 whole to the power 2 and 1 are given. You should write 2 plus 1 into. Now delete the row and the column through the element minus 4. That is second row and first column are deleted. What remains? Minus 1. So you can write it within bracket also minus 1. Right? Let us simplify it. So it is minus 1 whole cube into minus 1. What is minus 1 whole cube? Minus 1. So minus into minus is plus 1. That is your A21. Next one, you have to get A22. How can you get A22? A22 means cofactor of the element belonging to the second row and the second column. Second row and the second column. That means 3. 3 is the element. That is cofactor of 3. What is the cofactor of 3? First of all, you have to consider the sign. That is minus 1 to the power 2 plus 2. Is that clear? Into, now delete the row and the column to the element 3. That means second row and second column are deleted. What remains? 2 into 2. So it is minus 1 whole to the power 4 into 2, which is equal to 2. So I think you have understood it. Okay. Now let us write down the matrix B, whose elements are the cofactors of the elements of matrix A. Okay. So therefore, what is capital B? It is A11, A12, A21, A22. Right? So therefore, capital B is equal to, what is the value for A11? It is 3. What is the value for A12? It is 4. What is the value for A21? It is 1. What is the value for A22? It is 2. So I think I have understood it. Right? So now, you have to get the adjoint of A. So how can we get the adjoint of A? That is, it is defined as transpose of B. Right? So now, therefore, ABJA is equal to B transpose, or now ABJA is equal to, what is B transpose? In matrix B, you have to change rows into columns and columns into rows. That means this first column becomes the first row. That is 3, 1. Let us write it within the first bracket, because in the question first bracket is given, right? 3, 1, and second column becomes the second row. That is 4, 2. So this is your adjoint of A. Is that clear? So now how can we get A inverse? In this case, A inverse exists because data is not equal to 0. So now you should know the formula of A inverse. That is, A inverse is equal to, what is the formula? 1 upon det A dot ADJA. Right? This is the formula. So now, therefore, A inverse is equal to, what is 1 upon det A? It is 1 upon 2. Det A value is 2, isn't it? That is 1 upon 2. What is ADJA? We just found it. This is 3, 1, 4, 2. You can keep the answer like this also, or you may simplify it. And you know that this half is the scalar multiplication of this matrix, right? So you have to multiply each element of this matrix by this scalar quantity half. That means what do we get? It is 3 by 2, half into 1, half into 4 is 2, half into 2 is 1. So this is the answer. So this A inverse is the inverse of the given matrix A. But अब तिमीहरुलाई डाउट लाग्यो सपोज यो इन्भर्स है मेरो रङ आयो भनेर हैन कतैतिर रङ भयो भनेर सम्झेर सपोज है कतैतिर क्याल्कुलेसन रङ हुन सक्छ त्यसको लागि अस्ति नै अनलाइन क्लासेसमा एउटा मेथड सिकाएको थिए A dot A inverse is equal to I 1001 and that is the correct answer for A inverse. Let us check it. Okay, हामीले खाली चेक मात्रै गरेको है यो. So if you are confident that your answer is correct, no need of checking it. But if you don't have any confidence, then you can check it. Okay, so A dot A inverse, let us check it. This is just checking, right? So now what is A here? What is the given matrix A out here? 2 minus 1, 2 minus 1, minus 4, 3, minus 4, 3, right? And what is A inverse? Just now we got it. That is 3 by 2 half, 3 by 2 half, and then 2 1, 2 1, right? So let us multiply these two matrices. You know how to multiply them, right? First row by first column, 2 into 3 by 2, that is 3, minus 1 into 2, minus 2, right? Then next 2 into half is 1, minus 1 into 1 is minus 1. Then second row by first column, minus 4 into 3 by 2, that is minus 6, 3 into 2 plus 6, right? Minus 4 into half, minus 4 into half, what is that? Minus 4 into half is minus 2 plus 3 ones are 3. So which is equal to what is 3 minus 2? That is 1. 1 minus 1 is 0. Minus 6 plus 6 is 0. And minus 2 plus 3 is 1, which is equal to I. That means we are getting A dot inverse is equal to I. So this is the correct answer. Is that clear to all of you? So I think you have understood the topic that we discussed today. So you can revise it at home. So this much is for today. Okay. So in the next class we'll do more problems. Okay.